Okay, so this video is going to cover the review guide on section 3.6. I apologize, I made it yesterday in class, and then I totally forgot to post it. And then I decided I didn't really like it because we were talking through the problems. So I decided to just make it at home. So I'll post this for y'all that have been absent most of the week so that you have it as a review. But let's go ahead and get started. Okay, so on the review guide covers everything that we're going to see on the quiz. Starting with number 1, you have a linear equation with 3 variables. You've been given your ordered triples, and so you just need to plug in those values in order to find out which one gives you a true statement. So let's go ahead and start with the first one. I'm just going to draw a line here. I apologize. I don't think I gave y'all much room. All right, so I take my equation. So 15 times x, remember these are your x, y, and z coordinates. So 15 times 4 minus 10 times y, which is 3, minus 6 times 5, which is z, gives me equals negative 30. All right, so let's see if it's true. 15 times 4 is 30. No, it's 60. So tired. 10 times 3, so minus 30, and 6 times 5 is minus 30. That equals negative 30. So we already can look at this hopefully and see 60 minus 30 is 30. 30 minus 30 is 0. So we're about to end up, this one's not true, right? So we end up with 0 equals negative 30, which is not true. So that one is a bust. All right, let's try the next one. So the next one, try not to mark through it here. 2, 0, and negative 1. So the 0 represents y. So that means my y term, I'm just going to completely eliminate it. I don't need it. It's 0. So this is 15 times 2 minus 6 times z, which is negative 1. So this is definitely not going to be it either. Equals negative 30. But let's work it out. 15 times 2 is 30. Negative 6 times negative 1 is positive 6. So that equals 36, which is not negative 30. So again, that one's not true. All right, so not B. So probably C, but let's go ahead and do the work and double check. Let's see. We'll do this one. All right, so for C, I have negative 2. So 15 times negative 2 for X, minus 10 times negative 3 for Y, minus 6 times Z, which is 5, equals negative 30. All right, 15 times negative 2 is negative 30. Negative 10 times negative 3 is a positive 30. So we just canceled these guys out. And this is negative 6 times 5, which is negative 30. And that does equal negative 30. So our answer is C. Okay, moving on. All right, so the real clue for sketching the graph is that they are asking you to state the x, y, and z intercepts, which means that all you essentially do is you calculate your x, y, z intercepts, and then you draw the traces that make up those intercepts, and that gives you your solution, your plane. Okay, so what do we know about our x, y, and z intercepts? Well, for the x-intercept, what is y and z? They're always 0 when they intersect the x-axis. We have the same thing, but different for the y-intercept. Where x is 0, y is some value, and z is 0. And then lastly, z-intercept, 0, 0, z. So you now have values for 2 of your 3 variables to plug in and solve for the intercept of each of these axes. All right, so let's start with x. So for the x-intercept, we know that x is some unknown. So this is just 30 times x. The other 2 terms are going to be 0 because they're times 0. So we just have to write 30x equals negative 60. You divide that by 30, and you get x equals negative 2. Now, the important part of this is that you have to write these as the ordered triple, your x. So the x-intercept is negative 2, 0, 0. Y-intercept, okay, I'm going to use my y term. So this is 20y. I'm just going to Just try to stay consistent. 20y equals negative 60. I divide both sides by 20, and I get y equals negative 3. And so my y-intercept falls at 0, negative 3, 0. Lastly, the z-intercept. So I'm going to use my z term. So that's 15z equals negative 60. Divide both sides by 15, and z equals negative 4. So 0, 0, negative 4. Okay, all of these are negative. The important thing about using the 3-axis graph is to remember which direction is positive, because it's the opposite of what you might intuitively think on that diagonal axis. So this is, oops, excuse me. So this is positive z. This is positive y. And they're labeled z, x, z, and y. And this one is positive x. And when you look close here, I think on most of them, some of it didn't quite translate. It shows you, right, that the northeast direction of the x-axis is your negatives. But that's the one that you really got to kind of keep an eye out for. Make sure you don't graph incorrectly. All right, so let's go ahead and graph these. So my x-intercept is in the negative 2. So I look at my x-axis. I know negative 2 is this up. Oh, it's going to be like that, huh? Or it hates me. Negative 2, right here. All right, the y-intercept was at negative 3. So that is left of the origin, so right here. And then z was negative 4, which is down from the origin, right? This color, right about here. All right, so let's graph it. All right, so remember to make sure that your graphs go to the edge of the Cartesian plane that you've got, and that they have the arrow on the end, because this is like, it creates a three-dimensional, a plane, a flat two-dimensional plane in a three-dimensional space, because you've got the 3 axes, but it's going in all directions. All right, and so now let's draw our y-z trace, which is something like this. You know how epic my drawing skills are. All right, and then the last one is this guy over here. I do like to highlight, even though it doesn't, this is not a solution set, like with our inequalities, I kind of like to highlight that to show my lines versus the axes. That's not necessary. All right, and we're done, right? We have our x, y, and z intercepts. We've graphed the traces for those intercepts. We're done. Okay, so now into kind of the meat of this, where we solve these systems algebraically. All right, so our first example, number 3, we have 2 equations. So I always like I like to number these equations, 1, 2, and 3. All right, so equation 1 only has 2 variables. Equation 2 only has 2 variables, but they're different. It's a different kind of pair of variables. So I can't like just go ahead and eliminate one. I can't really pair those together and do much good. I'm just going to create another 2-variable equation with y and z, because the only one I could eliminate is x. So again, be careful that you don't create this sort of infinite loop of constantly eliminating variables, but still having the other 2, and you just keep going. So what I'm going to do is I just pick one of these 2 equations that I want to use the other 2 to make a matching equation. You can use either one. It doesn't really matter. But I kind of like how this one looks. And I noticed that with my 3y and y, I'm not going to have to use super big numbers to create an equivalent equation. So I am going to pair up, so let's do step 1. So I'm going to pair up equations 1 and 3. So this is 5x plus 3y. I'm going to put a space for z, just 0, because I like it. It makes my brain happy. And then I'm going to take equation 3x plus y minus 5z equals 7. And I am going to eliminate the y variable because when I do, it will create an equation that only has x and z, which just so happens to match the unknowns, the variables in equation 2, x and z. Then I can take those equations and get rid of one of my variables. Okay, so let's go back to this pair. So I know since I'm getting rid of y, I first look at their coefficients. One is 3, one is 1. So obviously the second equation, I'm going to have to multiply times 3 to get the same coefficient. However, I need the opposite sign. And when I look at the sign of these, they're both positive. So I'm going to have to multiply times a negative so that I have a positive 3y and a negative 3y, and those additive inverses cancel each other out. So I'm going to rewrite the first equation so that I'm keeping everything together. 5x plus 3y. I'm going to keep the 0. You don't have to. But it keeps everything lined up neatly for me. Negative 3 times 3 is negative 9x. Negative 3 times y obviously gives us our negative 3y. So we cancel that out. Negative 3 times negative 5, though, gives us a positive 15z. And then don't forget 7. This is negative 3 times 7, which gives us a negative 21. All right, so we're going to add these together. 5 plus negative 9, that's negative. So we're subtracting. So our answer is going to be negative 4x. These cancel each other out. And then we actually just bring the 15z down because we're adding it to 0. Okay, 17 and negative 21. I know my answer is negative because 21 is a bigger number. 21 minus 17 is 4. Yeah. All right, so now I have an equation, negative 4x plus 15z plus 4 that matches my second equation, 2x minus 4z equals 2. So I'm going to move on to step 2. And I'm going to create a pair with these two. So I have negative 4x plus 15z equals negative 4. All right, my second equation is 2x. Oh, this is going to be nice. 2x minus 4z equals 2. All right, so good news. The x, it looks like nice and easy. It's very obvious that your least common multiple here is 4. So I don't have to change the first equation at all. And one's negative and one's positive. So I can, let me use that other color. I can multiply times a positive number, not 3, 2. And not have to worry about getting my negatives mixed up. All right, so let's do this. I'm going to rewrite the first equation like I did before so I don't get confused. Negative 4x plus 15z minus 4. 2 times 2 is 4. 4x. 2 times 4, that's negative 8z. And 2 times 2 is positive 4. All right, so we eliminate x. Let's solve for z. 15 minus 8 is 7, so 7z. Negative 4 plus 4 is 0, which is fine. That works. Because when we divide by 7, we find that z equals 0. So we have our z value here. All right, so now that I have z, I am going to go back to equation 2. I already have an equation where I have an x and a z. And so I'm just going to go ahead and use that. So equation 2 has, it's a step 3. Okay, so equation 2 is 2x minus 4z equals 2. Well, if z equals 0, then that minus 4 times 0 is just 0. So this actually simplifies to 2x equals 2. And then when I solve it, I divide both sides by 2, and I find that x equals 1. I'll plug that in to my x coordinate. And last step, we got to solve for y. All right, so you can do it either way. You can use equation 1 and 3 both have y. I'm going to use equation 1 because, actually, no, I'm going to use equation 3 because I know my z term is just 0, right? That's negative 5 times 0, so that eliminates it as well. And my y has no coefficient, so I don't have to worry about dividing anything. So 3x plus y, both will work just fine. It doesn't matter. 7. Okay, so this actually cancels out because that's 5 times 0. So whatever. All right, and I also know that x is 1. So this is 3 times 1 plus y equals 7. 3 times y is just 3. So I'm going to subtract 3 from both sides. And I get y equals 4. And I'm done. So my ordered triple is 1, 4, 0 for the solution. All right, let's do it one more time. Practice, practice. Okay, so for this one, I have two equations with two variables, or all three variables, but then I also have an equation, y minus 2z equals 5. When I did this in class, I actually, oh, do I want to do that? Yeah, we might as well. Okay, so what I did is I actually just created this as a value for y, and then I plugged that into the other two equations so that they both became two variable equations. And then I continue to eliminate. So let's rewrite this as y equals 2z plus 5, right? I add 2z to both sides. And so I end up with an equation with a value for y. So when I do that, I take the other two equations. So this one is x, first one, again, 1, 2, 3. X plus 5y minus 3z equals 19. I'm going to plug in the 2z plus 5 for the y. So x plus 5 times 2z plus 5 minus 3z equals 19. Distribute your 5. X plus 10z plus 25 plus, excuse me, maybe, come on, minus 3z. All right, so I'm going to kind of do two things at once here. I'm going to subtract this 3z. So I'm just combining like terms on the same side of the equal sign. So the sign stays the same. But I am going to move this 25 over and use the one of the addition property of symmetry. So that eliminates that there too. Why that bothers me. Okay. So this becomes x, 10 minus 3 is positive 7, x plus 7z. And then 19, 25 is greater, so my answer is going to be negative. 25 minus 19 is 6. All right. So that created an equation with x and z. So let's do the same thing with the second equation. 2x minus 3y plus 4z is negative 11. All right. I'm plugging in the y. So 2x minus 3 times 2z plus 5. That's 4z equals negative 11. All right, so let's distribute 2x. That's a negative 6z. Negative 3 times positive 5 is negative 15 plus 4z and equals negative 11. All right, so again, I'm going to combine both of these. So I'm going to add the 4z to the negative 6z, but I'm also going to move this negative 15 over. So that's actually plus 15 to both sides. So I'm left with 2x. Negative 6 plus 4 is negative 2z. Those canceled out, and 15 minus 11 is 4. Okay. So we can simplify this. You don't have to, but I'm going to. Because all of the coefficients are multiples of 2, I'm going to create an equivalent expression that is x minus z equals 2. All right, so we now have two equations with only two variables. So now that we can eliminate one. Okay, let's go. Sorry, I am super tired. I'm going to try to make through this without making a mistake or too many big mistakes. All right, I'm going to do step 2 over here. Okay, let's take my two equations. So x plus 7z equals negative 6. Okay, so hopefully you guys understand. But an equivalent expression, if I multiply this whole thing times, let's say negative 1, I get negative x plus z equals negative 2. And so I'm going to rewrite it like that because that goes ahead and creates a variable that I can eliminate. So now it's plus z and it's minus 2. Okay, so by doing that, same thing, just an equivalent expression, equivalent equation. I cancel my x. 7z plus z is 8z equals negative 8. And when we divide both sides by 8, we get z equals negative 1. So there's my first variable. Now that I have that, I'm actually going to go back to the equation I just made, the x minus z equals 2. I'm going to plug in the z and solve for x. So we'll call that step 3. So I have x minus z equals 2. I know that z is negative 1, which is the same thing as a positive 1, since x plus 1 equals 2. And so I subtract 1 from both sides, and x equals 1. I'm done with my x value. Also, I'm going to go ahead and use equation 3, y equals 2z plus 5, because I know z is negative 1. And so that's kind of easier to solve for my y. So like I said, you can use all of these equations are representations of the system. They all will work within the system. So you could use any of them as long as you did your math right for any of the ones that you adjusted. Okay, so I'm going to go back to y equals 2z plus 5, which means it equals 2 times negative 1 plus 5, which is negative 2 plus 5, which means that y equals 3. And I'm done. So don't forget to put it as an ordered triple. So x is 1, y is 3, and z is negative 1. And you're done. Okay, let's move on to the word problems. Okay, so this first one is not really anything a good representation of what you're going to see on your test, but this one I thought might be helpful for you guys to understand the process. Because when you read it, you find that even in your head, maybe with some small subtraction, you can figure out the price of each of these items, the burger, the fries, and the drink. So you already know, just from doing some subtraction, that what your answer is, essentially. But I want you to focus on the process, because obviously that's not the case most of the time. So this way you can solve for each variable, and you already know what your prices are going to be. All right, so let's go ahead and first define our variables. So we have a burger, a fry, and a drink. So I'm just going to use B. That's the burger, if I can spell. F is the fries, and D is the drinks. All right, now that I've defined my variable, go to my problem. Adrian, Nathan, and Brian bought lunch from the concession stand. Adrian paid $5.50 for a burger, fries, and a drink. He got all of it. Nathan paid $4 for a burger and a drink, which means the difference between those two is the price of fries, so $1.50. Brian paid $4.25 for a burger and fries. So we need to write 3 equations that models the cost of their lunches and then solve to determine the price of each item. Like I said, pretty easy to figure out, so you know what your answer is going to be. But first, let's work on making those equations. So first off, we know, based on what Adrian bought, that the price of a burger plus the price of fries plus the price of a drink equals $5.50. I know that based on what Nathan bought, that a burger and a drink is equal to $4. And I know based on what Brian bought that a burger plus fries is 25 cents more, $4.25. Okay. So I'm gonna do something similar to what I did in the previous problem. I'm going to actually, I'm going to use the second equation. Let me label them 1, 2, and 3. The second equation, because it has a whole number before, I'm actually going to rewrite that as, so B plus D equals 4. I'm going to solve it for burger. So I'm going to solve for B and then substitute that in the other 2 equations. So a burger is minus the price of a drink plus $4 or whatever, 4 minus D. Anyway, so now that I've got that, I'm going to plug that. Step 2 means I plug that into my 2 equations and create, yeah, I got plenty of room. So that means that B plus F plus D equals 5.5. So this is negative D plus 4 plus F plus D. Oh, this will be nice. We can actually go and solve a variable. All right, so when you do this, you'll notice you have a negative D and then you have positive D. When we add D to negative, they cancel each other out. So, and I'm gonna go ahead and move this $4 over. So that cancels, and I'm left with the price of fries, which is $5.50 minus 4, so $1.50. That helped. Okay. Sometimes it just works out that way. All right, so now that I have the price of fries, I'm going to use equation 3 to solve for the price of a burger. Because just saves a little time. No need to use anything else. All right, so now that I know price of fries, I know that the burger plus the fries is $4.25. Fries are $1.50. I just subtract that. And I know now that a burger, 5 minus 0 is 5, 12 minus 5 is 7, 3 minus 1 is 2, and a burger is $2.75. All right, I told you it was easy, but still, it's a focus on the process. Process is always the same. And again, the main part of the process is making sure you're not just going in circles and never quite eliminating a variable. All right, so for the last one, I have burger fries. I need drink. So I'm going to use equation 2 again, because now I know the price, what B stands for. B is 2.75. So I can plug that in and solve for drink. So B plus D equals 4. Burger, excuse me, burger is 2.75. Subtract that from both sides. Zeros, so you don't mess up. All right, so we know that's 25, and I'm gonna have to borrow 3 minus 2 is 1. So a drink is $1.25. All right, so we're done. Burger is 2.75. Fries are $1.50. A drink, $1.25. All right, we're good. And that's the other part. We needed those two. All right, so let's move on to the one that is a little more of a representation of what you're going to see on the quiz tomorrow. Today? Yesterday. Depends on when you check it. I've had a lot of students out this week. Okay, so Mr. Jonas invested a total of $10,000 in 3 mutual funds: a growth fund that lost 8%, a balanced fund that gained 3%, a bond fund that gained 2%. Okay, so because we're talking about an investment as opposed to accounts that accrue interest, you have the potential for negative. This is like the stock market. You lose, you gain. It just depends. All right, so first let's define our funds. We know I'm going to use G for growth fund. I'm going to use B for balanced fund. And since I don't want 2 B's, I'm going to use N for bond. All right, so there's my 3 variables. These represent the money he invested in the account. So we can write an equation that explains the money. We know that the money he invested in the growth account plus the money he invested in the balanced account plus the money he invested in the bonds account equals $10,000. There's one equation right there. All right. The second equation, which I probably should have put first so that I could simplify it, is the one that is a representation of the money he made, or in this case, lost, because he lost $160 on his investment. So that means we got some negatives. Now, we know that the growth fund, he lost 8%. So there's our negative. I'm going to go ahead and convert it to a decimal. So this is negative 0.08 times the money invested in the growth account plus, because the other two are positive, the 3% gain that he had on the balanced account fund plus the 2% he gained on the bonds. And we know that equals a negative $160 because he lost money. All right, so what I mean by simplifying is I'm getting rid of these decimals. I don't like them. All right, now my smallest decimal is in the hundredths place, so I'm multiplying the whole thing times 100. So that moves my decimal 2 places to the right. So this becomes -8g, same color. -8g plus 3b plus 2n, and then just tack 2 zeros on that 160. And we get -16,000. All right, there's my second equation. I'm just going to put it right over here. -8g plus 3b plus 2n, -16,000. Now, the last one can be a little bit tricky. If he invested $2,000 more in the growth fund than in the bond fund, how much did he invest? So I'm going to put in my equal sign. Here's the important thing. The temptation is to write n equals g plus 2,000. The problem is we want to represent balance. So what we're saying here is there is $2,000 more in the growth fund than in the bond fund. So the growth fund equals the bonds fund plus 2,000. So that's just it's kind of the important thing. You could also write that as g minus n equals 2,000. The difference between the two is 2,000. Either way, but just make sure the growth fund, in order to make them equal, because we know more money was put in the growth fund, the amount of the growth fund equals the amount of the bond fund plus 2,000. So just make sure you don't get those flip-flopped. All right, so here is the first question that we're asked. Here's our 3 equations. So now it's time to solve them. Again, we have a situation where the g variable is already defined in terms of n, g equals n plus 2,000. So we could take our other 2 equations and plug in that for g, and we'll create 2 equations with only variables for b and n, and then we can work on solving. So let's go ahead and do that. I think that's probably how it's going to work on the test. So we might as well practice with the substitution instead of doing pure elimination. Okay, so let's go ahead and do that. So step 1, we write our 2 bigger equations with 3 variables, g plus b plus n equals 10,000. All right, I'm going to go ahead and substitute equation, so 1, 2, and 3. I'm going to substitute equation 3 in the value of g for the g. So this is n plus 2,000 plus b plus n equals 10,000. Okay, when I do that, I'm going to go ahead and add n to n, just combine like terms. But I'm also going to move this constant variable to the constant term, excuse me, to the other side. Get rid of it. So that eliminates that as well. So I'm left with b plus 2n equals 8,000. Okay. So let's do it with the other equation. This one's a little bit bigger. -8g plus 3b plus 2n equals -16,000. So it's g that we're substituting. So this is -8 times n plus 2,000. This one we do have to make sure we distribute because we have a number, not just one. Okay, plus 3b plus 2n equals -16,000. All right, so when we do the math, -8 times n is -8n. -8 times 2,000 is -16,000. See another cancellation in our future. Okay, plus 3b plus 2n. Those stay the same, but I'm keeping them so I don't lose something. All right, so let's combine our n terms while also moving that 16,000 to the other side. All right, so I'm just going to add, actually, no, I'm going to subtract 8, move that guy there. To get rid of this, because I'm doing it across the equal sign, I've got to add it. All right, so the 3b comes on down. 2n minus 8n is -6n. And -16,000 plus 16,000 is 0. All right. It'll be same. It'll be same. You don't have to, but again, like I just like the smaller I can make my numbers, the better. We have a greatest common factor of 3 in all these because 0 is just 0. So this actually gives me b minus 2n equals 0. You can use the original if you want. You'll probably, well, you will. You'll get the same answer. But the nice thing about this one is when I pair it with its partner here, you'll notice that I can eliminate the n variable. So I'm going to do that. It makes me happy. All right, so step 2. So I have b plus 2n. I hope I'm not messing something up. I'm not making this video again. Y'all just have to erase it and suffer with me. I am so tired. I just feel like I'm making a silly error. Let's see. All right, so this is, we're adding these together. And nice, neat. I've got a positive 2n and negative 2n. So these are going to cancel each other out. This is b plus b. Don't forget that. So that's 2b, or not 2b, sorry, equals 8,000. And then when we isolate the variable, we divide by 2 and b equals, yeah, that looks right. I feel like that's familiar. So b equals 4,000. All right, so that's the balanced account. So that's 4,000 invested at 3%. All right, so I'm going to go ahead and what do I want to use? I guess it really matters. I'm going to use the, let's see. I'm going to use the equation, the b plus 2n equals 8,000 to solve for n. I'm going to use any of them. I'm going to use that one. Yeah. Because once I have n, then I can solve for g with that original g equals n plus 2,000. Okay, let's do that. All right, so b, and I don't want to fool with that 0. B plus 2n equals 8,000. B is 4,000 plus 2n, 8,000. Subtract 4,000 from both sides. Get 2n equals 4,000 by 2, n equals 2,000. So that's my bonds account. So that one is 2,000 invested at 2%. All right, so the last one is G. So I'm going to use my equation from the original set. Step 4, G equals N plus 2,000. So G equals N, it's 2,000, plus 2,000, G equals 4,000. And that is at a loss of negative 8%. All right, and we're done. Now, I know mine looks enormous. A lot of that is because I took my original equation, I wrote it in its base form, plugged in numbers. I did do a lot more. I did the baby steps because I wanted y'all to have everything available to you in your review. Yours might or might not take up that much room. Totally up to you. But hopefully this answers any questions that y'all have. We got to work on this problem, which we didn't have time for in class. But hopefully that'll help you out. All right. Thank you so much. And hopefully I'll see y'all that have been missing. Hopefully I'll see you soon.